Welcome, everybody. Tonight is the 8th of February in Dallas. This is the Dallas Personal Robotics Group Robot Builders Night Virtual. We'll do what we normally do, rolling around the table and giving updates, asking questions, mainly focused on robotic-related things. Just a super brief housekeeping. On the right-hand side here, we're still looking for someone to offer to run as president. We could find vice president candidates, but we're still searching for a president candidate. So until then, it's kind of a free-for-all. I'm serving as the interim president. You may have noticed we do have a monthly meeting scheduled for February. Jack Jones has got his robot journey presentation ready to go. Kind of cool. We can see what he's been doing with DPRG since he learned what an O-meter was to making a robot that drives itself to the golf course with drinks in a cooler. And that's what we have on the agenda. The handful of other items notionally, but nothing scheduled, nothing else scheduled. Any other housekeeping items anyone would like to mention before we dive right in? Okay. Well, if you all don't mind, I would ask, and I'll put this online for later joiners. So, Ray, if you could kick us off, and then if you all could just kind of pass the baton, maybe make a note when you start so that we have in the record, in the call notes, we can add that to the meeting recording on the website. And other than that, Ray, take it away.
Okay. Well, I was looking at, there's a lot out there, different mechanisms to control CNC machines. And being kind of a fan of the ESP32, this one was based on an ESP32. It's Bart Dring, I think is how you pronounce his last name, D-R-I-N-G. Had a bunch of products. Let me present now. Check your screen. Okay. So, and one of the ones, whoops, there we go. Can you see that on the screen? Can anybody see that?
Yeah, yes, I can see it.
Oh, okay. Anyway, so this was one of them. It's Gerbil ESP32 CNC development board. Very good price. This one used one of the 38 pin Vroom-based modules. It was pretty much all I needed. Thing is, he was kind of out until February 2nd, sent him a message. He was out of these boards, and that's what I really wanted. And so I asked him if he's, when he was going to produce anymore. And he's kind of lost interest in it, and he's moved on to another board, which is the 6-axis one, which I don't have any machines that have any more than 3 axes. So I don't know if I'll ever buy one of these. He did provide like Gerbil files for this one. So I could make the board if I wanted to. It's open source, but I kind of put everything on basically a little proto board. Had a LCD display that had an SD card reader on the back, and that's hooked up to the ESP32. And I also put a buffer. This one is an ACT 244. I actually wanted the 245, but didn't have one. So use one of those because the current output for the individual pins in the ESP32 isn't that high. So using one of those devices, it gets it up to 5 volts. I'm just using them as outputs, not as inputs, to the ESP32. The 6-step and direction outputs, one for each X, Y, and Z, or two for each X, Y, and Z axis. So anyway, he's got basically a setup where you can communicate over Wi-Fi and download files. And fluid term. I can set that up and say Control R. Okay. And where is the URL? Okay. Usually it pops up with the URL in here somewhere. Could be demo mode already. Don't know. Let me see if I can just get to it. Let's see. Forward. Fluid and see there. There it is. Saying can't reach this page.
Ray, do you think you're presenting?
No, I was just trying to get something up so I could show it to you here. But for some reason. Let me see if I can get it again here.
It's a little bit of a Murphy's Law situation.
Probably.
Doug, are you DPRG clips?
Me? That's the club. DPRG Clips is the club.
Where are you?
Where am I?
Yes.
What do you mean?
Yeah,
I mean, I have windows that say Carlot, and
he is logged in as DPRG Clips to this meeting.
I am.
there we go.
Yeah.
you are, Doug, which means if anybody knocks, you can let them in.
Hmm.
Well done.
Okay, I'm going to go back to present mode. I got it up.
I don't think so. Carl.
You are logged in as that. This lights up whenever you speak.
Unless you've named your personal account DPRG Clips.
And there is no other window that says Doug Parody on it.
Well, that might not be your makerspace email, so you're right, Doug. You might not be able.
No, I think I know what's happened. I was working on the website and I probably just clicked while logged into the website. That's probably what went on.
Okay, so I got it up. So one of the things that you can do is, you can set this up for different machines, and you basically have to just tell it what that file is, and it's a YAML file. YAMLs apparently have a certain format and accept certain characters, and so you can do it for a 3-axis machine, a 6-axis machine, a plasma torch machine, pretty much lasers. He's got a setup for just about everything in there. And one of the things you can do, take the firmware, manage local files. I think, was it here? Yeah, manage local files. So you can get rid of whatever files are on the part. Like if you wanted to change the config.yaml file or something. One of the other things that you could do, if you go over to the dashboard, you could look and see what's on your SD card. So these would be all the G-code files that I could download to it. Most of these are for 3D printing, but there's a couple in here that are for like a CNC mill. So I could download those to it and play it if you wanted. Any of the ones with an arrow here, you can, after you do machine setup, you can actually run through it. So one of the other things you can do, like here, is a send command if you wanted to do just a simple, you know, like horizontal or vertical traverse. You could do like a G1, you know, X100, which would mean it would go to, you know, X at a, you know, position 100 millimeters, and you could specify a feed rate. In fact, you have to, otherwise it won't work. And have the machine traverse there to that part, or sorry, to that place. These, you know, that's kind of traditional stuff. It's like 0.1, 1, 10, and actually 100. Let's see, 0.1, 1, 10, and 100. Yeah. So you could, like if I hit, boom, that should put the X up to, oops, got to unlock first. Forgot about that. Let's see. I think, oh boy, I forgot where you unlock. I don't know if it's here. I think it's $U. Okay, nope, wasn't $U. $X maybe? Yeah, so that you have to unlock it before it'll move. So if I clicked, that should be 10. X should go to 10, and you can see it's updating here. You can, for some reason, this update is fairly slow. I kind of like it on 1 second, but it made it to 10. If you go back, this should go back to 9, and so on. So you can basically position it around. You can set the home for X, Y, or Z, or just all of them. You can zero out coordinates here. Like if I wanted to, you know, say that was my origin, you know, you can zero out the individual places there. So it's kind of neat. It doesn't, some of the one, he's got, you know, a bunch of machine control buttons over here for feed rate and spindle speed. And whether you can turn on flood or mist for, you know, cutter coolant, that kind of stuff. A lot of other people put in, it's kind of a screen that shows toolpath. So you can actually have it, you know, draw a picture of what the tool is actually going to do. And that can be useful for, you know, debugging programs like the first time you run it to make sure, you know, it's doing what you kind of expect it to do. So anyway, and this just spits out, you know, the information about like machine position and stuff like that. But anyway, and this is done, you know, over Wi-Fi to the part, which is kind of nice. But so that's kind of where I'm at. I got that together. Checked it out. Basically, I just, you know, it's sitting on a prototype board with the, you know, like I said, the ESP32, the SD card reader, and basically a little buffer for the outputs. Haven't actually hooked it up to motors yet, but that's the next step. Anyway, I thought it was pretty neat. That was the first one that I had seen that actually used an ESP32 and kind of took advantage of some of the features like Wi-Fi to, you know, be able to communicate to the machine, download whatever your files are that you want to actually cut with to the machine, and it made it standalone, because a lot of the systems are not standalone, and I don't like that. I kind of like to, you know, just say, okay, you know, it's like with 3D printer files. I don't want to sit there and listen to my 3D printer and smell it and, you know, all that stuff. So I don't like the smell of the burning plastic. But anyway, that was all I had. that's my update.
So Ray, it's kind of like an Octoprint for using the ESP32 web server.
I guess it's similar to that. Yeah, you can, download files to it. It's, what do they call those? Like universal G code senders.
Yeah.
It basically does that function local. It's
Right.
not your laptop, with a G code sender running on it, sending, parts, lines for the G code file to the board so it can implement them.
I still would say, what do they call it? Laser cut? No, it's not laser cut. I mentioned it. Laser burn.
Oh, light
No.
burn?
Light burn. Yeah. Excuse me.
Yeah.
They have I think you can use it for 2 weeks or a month or something like that without any charges. I think you might want to take a look at that. That's pretty cool interface. It's got all of what you're showing. That thing that's up in the corner, the one with the concentric rings and the home corner in the corners, that I believe comes from whatever the main open source slicer program. And I want to say RP Splicer or something. So, I mean, that's straight out of that.
Yeah, that seems like a common interface. He seemed to like it, so he's used it. So
yeah, it's very compact.
Yeah, so you have pretty much all the, well, not I guess all of them, but a lot of the machine control functions just in that block. So
Yeah.
you can basically set it up, set your 0 point, and if you need to play with feed rates and that kind of stuff, you can do it there. So that's kind of nice. I think if you're doing like production pieces, that's something you might want to do to just kind of make the whole process more efficient, take less time. So to, be able to adjust feed rates as you're working, or as the program is making the machine cut whatever part you're trying to cut out. But so it seems like okay, this one is for the ESP32. Somebody's done one for the Blue Pill. There's another person that's done one for the 32F, like 401. So you've got an M4 with hardware floating point. So that's kind of nice. So
they're super durable too.
Say that again.
Super durable.
Yeah, I haven't seen anything that's super durable yet. It seems like
really
there's
nice.
a lot of,
It's a real nice board, though.
Say it again.
It's a nice board.
Oh, it's a board. Okay.
It basically has the drivers on it, and it doesn't have drivers that'll push what you would need for your Bridgeport, but you can steal the signals from it and go through a more robust driver.
Right. Yeah, and so a lot of in fact, he does that with his thing. He's got basically sockets, so you can get the enable step and direction signals from the board and bring it to a more powerful off-board motor driver if you want to.
That's kind of the nice part about having it not be the kit on the board. You could do custom. You could fiddle around with different motor drivers on your breadboard. So,
Right. And in fact, I think he's got it set up so there's like a list of drivers that he supports that you can put in the sockets, or if you want in pretty much you pick and choose what you want for each of the drivers, because they may be, different sizes for different machines. Like for plasma torches, I mean, it just has to move at a very small amount. It just has to basically lift the weight of the handle. It's not like it has to produce a lot of torque to do that. So you could have a small stepper for that and larger steppers for the X and Y if you want, if you need it, maybe for speed or something. But so yeah, it's like tons of options out there now for that kind of stuff. Oh, Kareem, I want to ask you, did you ever use there's a simulator that comes with Mach 3? You're muted. I couldn't hear.
I had no idea that there was a simulator with Mach 3.
Oh, okay.
We've only used it to directly control the machine.
Yeah. Let's see. Hold on a second.
Well, let me rephrase that. You can actually play the G code inside the little window if that's what you're talking about.
Yeah. No, this is
So
called
it just shows it.
Camotics, CAMOTICS.
No, not familiar with that.
Oh, okay. Yeah, I was kind of curious. I think it's kind of nice if you can just, it actually starts out with a block and looks like it, whatever you're cutter with, it scales it to, the block, and, kind of shows the tool path and it removing material. And so it looked kind of neat.
We do that in Fusion before we export the G code.
Oh, you do? Yeah.
Yeah.
But yeah, it looked like, something quick if you want to do a quick check to see if,
That would be helpful if you didn't have it in Fusion anymore and you were just had like an old G code file and wanted to see what it would do.
Yeah.
Without, doing an air pass or something like that.
Yep. Anyway, that was all I had.
Cool.
Who's next?
Pat is next.
That would be me. So last week I gave an update on my robot on using MQTT versus RabbitMQ, with MQTT being first in, first out as a message bus, and which would give me problems because I wasn't able to limit the queue size, and it would create a bunch of messages that were out of sequence for what the robot was doing. So I was looking into RabbitMQ, which is a last in, first out system, which you're also able to limit the size of the message queue as well, to say, okay, only keep one message or 10 messages as you go along. Well, I can report that I did manage to do a bunch more testing with some code. And the problem I ran into with RabbitMQ is that it's blocking code. So as it's waiting for the message to come in, it can't do anything else. So there is a way around it to wrap it in like an async IO wrapper and have it work. But I don't know if I'm willing to go down that hole to add another layer of complexity on top of a communication network. So I'm pondering what I'm going to do next. Think about it. I think Chris said last time, maybe you should go to ROS because it seems to do it quite well in the background. And I had dabbled in ROS previous to MQTT and RabbitMQ as a message bus, and it did work quite well without any delay. So
yeah, I was going to ask, just remind us why you've picked sort of MQTT or RabbitMQ. Just if you rewind way, how did this sort of get started? What did you want to get out of it?
So what I was looking for is a way to distribute my code through all cores on my Raspberry Pi, so that I'm not limited to one core and trying to max it out and then, switch to the next core. This way here, I can use a bash script to launch all my Python processes, and they'll launch on whatever's room is available. And I needed the way to tie them in because you can't do it through threading or multi-processing that way. So you need to have a message bus in the background that's able to communicate between everything. So I had looked at MQTT originally, but the problem I was getting is that some of the messages were being received faster than they could be used up. And so my queue would build and build and build. And eventually I'm 30 seconds behind on processing data.
So, okay. So, I mean, in a way, you want, let's say, a publish subscribe type mechanism, or something that gets all your Python scripts talking to each other. I would, I'd like to think publish subscribe probably would be the best pattern, right? I mean, that's what ROS happens to do for a reason. So the question is, can you do it in a way that's less complex and, getting all the way into ROS, right? Maybe that's what you're trying to do.
Yeah, so what I'm looking at right now is to use ROS as a backbone, essentially, just as the communication for inter-process communication.
Well, that's one option, right? In a way, that's what I'm doing. I mean, I'm probably doing a little more than that, but that's one way. The other thing I was going to suggest, because I briefly looked into it for the same reason that you have, right? How would I do it if I wanted to avoid using ROS? And I had a couple Python programs, and I wanted them to talk to each other. A zero MQ, zero message queue, was another technology that I looked at that's pretty popular and supports all kinds of different, communication patterns. I think including publish subscribe. So just throwing that out there as a keyword. I'd have to dig up some notes or some little tests that I did, but zero MQ might be another option for you if you really wanted to avoid ROS.
I was going to introduce another one. Pat, is this running on like a Raspberry Pi? That kind
Yes.
of thing? So have you looked into something we use in the all over the industry called a Redis cache? REDIS
No.
cache. Basically, it's I'm using on the project I am right now, and we're using it literally to communicate between different portions of the software. And what it is, it sits on the outside. It's its own process, and you can use it first in, first out. You can do a stack, you can do a queue, or you can do it, or you can do have some static variables. It's basically a durable in memory, but you can make it durable associated or a dictionary, if you want to call it that. So you'll have a key and a value, a key and a value, key and a value, and you can set it up so that that you get a queue. You can make it look like a queue. You can make it look a pop, or you can make it like, ooh, I want these settings for everybody. And you just set it in the Redis cache, and everybody references those settings from the first thing that sets it up. So it's REDIS is Redis, and then cache or cache, CACHE. And you might want to go take a look at that, because it's a process running out there. The things tend to be sort of lightweight as far as subscribing to a message, and you can get notified. It says, hey, something just showed up on this key that you care about, then go get it or do whatever you want to do with it.
So will it publish the messages? So like ROS or like MQ?
Yeah. You can
have
it's
just
got a notification system in it. So when somebody pushes something in it, another person on the other side will know that somebody pushed something in.
So you can have a callback function in the routine and it would grab it.
Yeah.
So Pat, you started out, you answered Chris's question about what's the background. Why did you step away from ROS in a way that I didn't understand? You said, well, you want to be able to launch these all these processes and have them use all the cores. But as far as I know, that is what ROS does on a Raspberry Pi. So can you go back again? why are you not using ROS?
It was the complexity of ROS, the uphill battle in learning it all is why I done it. Why I did it that way. So where I did manage to get, ROS communicating with my Arduino to move my motors and to read my ultrasonic sensors and to use a remote control to be able to move it around. I just found it was an uphill battle every step I was trying to go on. But trying to use another process, MQTT or RabbitMQ, those were the two easier ones I found. Chris, I did look into ZeroMQ as well. It starts to get a little more complicated, at least from what I was seeing on getting it set up and getting communication going between everything.
Okay, I mean, look at that. They support different patterns. And again, I don't remember when I did this. It says 5 months ago here. It's telling me I did some editing in this file. So I was looking at it. I was looking for publish subscribe type of pattern. It seemed to be working. I was looking at performance. I didn't write down the numbers because again, I wanted to be able to move, things around at 100 hertz without getting the whole thing bogged down. And I seem to remember it was able to do that. Yeah, I'd have to run some of these tests again to see if I did run into any kind of issues or something I didn't like, but it supports a lot of different ways of communicating. So I'd have to think it can probably do what you want it to do.
Okay, maybe I'll take another look at that. And I'm going to take a look at Redis Cache as well.
Maybe what you want to do is just get a little help from some of the folks in this club who I'm sure would be happy to do so to get you a leg up on ROS. But in response to Ray's question, the ROS for Dummies book is a gentle introduction to ROS, I believe is what it's called. And it's really, really good. And I'd be happy to help you see you in the right direction.
Okay, I think I've got an electronic copy of that book.
Yeah, Agitator, a gentle introduction to ROS. Oops, I think that's probably showing backwards, isn't it?
No, I had the same suspicion. It's showing okay for us, but in your own screen, it's showing it backwards.
Yeah, left is right in your own screen. It's really weird on this thing.
It's because it knows that you're used to seeing yourself in a mirror. So it presents you like you would normally see yourself.
Okay.
People get disconcerted about their symmetry.
Yeah. So that one's really good by Jason O'Kane. And the other one that's really good is, and I don't know if it's still in print anymore. It's sort of a bit out of date. But ROS by Example by Gerbil is really good. It's got lots of, it takes you on the next steps where a gentle introduction to ROS leaves off. And so it'll give you more advanced techniques. So gentle introduction to ROS will get you going on launch files and Python and C++ and publish and subscribe. The ROS by Example goes over that under basics, but then it gets into controlling a mobile base, navigation, path planning, and SNAM, speech recognition and synthesis, robot vision. So it goes a long way further. So I would recommend that you take another look at ROS and ping any of us. I'd be happy to point you in good directions if you want.
Well, that's been where I'm thinking about going because there is several guys in the group that are programming in ROS. So I think that might have more support out of the group than trying to do this on my own.
Yeah. Hey Chris, can you hold your book up again?
Okay, I grabbed those 3 titles. So one of the questions I had about ROS was, so there's a lot of material out there. So as you both showed a couple books, but there's ROS Indigo, there's ROS Melodic, there's ROS Noetic, there's ROS was it Kinetic originally? One of the few, not originally, but far back. So how much do they differ between the different versions on ROS one?
Use Noetic because and use Ubuntu 20.04. You want to use Noetic because it uses Python 3. All the previous versions of ROS use Python 2, which has been obsoleted. So then you get like warnings about ROS Python 2 is no longer supported, blah, blah, blah. I would say in general, it's pretty backward compatible. And most stuff that will run on Noetic really comes from Kinetic or Melodic. So Kinetic was probably the most popular version of ROS, I would say, of ROS 1 that was ever distributed.
Yeah, a lot of the books that they refer to Kinetic, so that's the thing you're gonna find with most of these books. They're gonna talk about that version, but like Paul said, I mean, all the fundamentals they've been unchanged for a long time in ROS 1.
Yeah.
Okay, I did install on a Raspberry Pi 4 with 4 GB memory. I did install ROS Noetic, so I put the desktop version on it, so I can get the graph and I believe a little bit of RViz, but I didn't put the desktop full on it.
So I believe you want to have, I assume you're using Ubuntu Mate rather than Ubuntu.
I'm using Raspbian or Raspberry OS or Raspberry.
Okay. So there's a I've seen a recommendation that you actually use Ubuntu Mate. You don't want to use full Ubuntu because it's too big, but Ubuntu Mate is kind of a stripped down Ubuntu. And if you try and use Raspbian, I think you have to compile ROS from source. If I read somewhere, it's just not quite as native. It's not going to be as natively compatible. You really want to use ROS with Ubuntu 20.04, and Mate is available on 20.04.
I'm going to agree with that because all the stuff I'm doing on my Twitch stream is messing around with ROS. Actually, what you may even get away with even faster than that, if you look out on Docker Hub and you're running ROS 1, there's all kinds of containers already ready to just download and start running and executing on your box. You don't have to install anything. Somebody else has already done all that work for you, and you fire up the container. And I'm doing ROS 2, so of course, guess what doesn't exist? ROS 2 on a Raspberry Pi and 32-bit doesn't exist. But so I had to go up to the Ubuntu 2004, and things are much better now. But I'm with Rudd.
The problem I've had with 2004 is getting it to boot from an SSD.
Rude.
Oh, I didn't. Well, that's a situation I haven't played with, so I stand corrected.
So Pat, I'm booting Ubuntu Mate 20.04 from an SSD, no problem.
Really? Okay, do you have a link to a site?
From an SD card. Did
you boot from an SD card into an SSD?
No, I'm running on an 8. I forget how big the SD card I got is.
No, he sounds like he wants an actual SSD.
I've been running on an SSD. There's a huge program speed gain by running off of an SSD.
Oh.
So.
Yeah, with Raspbian, you can boot.
Can I jump in, please? I want to mention another book, Practical Robotics in C++, Lord Brombeck. I tried to show it, but I just got the Kindle edition, and it doesn't show on my screen. And I'm pretty sure that ROS comes compiled now for the Raspberry Pi. He mentions it in his book that he just installs it. So.
Well, he might be running 204. I reached out to that guy, Rudd, because you had me interested with the book. I reached out to him, and it's all ROS 1. So he does the whole thing in there in ROS 1. So might be cool. Might be
What's the name of the book again, Rudd?
I put it in the chat. It's Practical Robotics by Lloyd Brombeck.
Yeah, he's got a Facebook page. He responded really quickly when I asked him a question.
Okay.
Hey, Harold, could you put a link in the chat from the Redis Cache that you were talking about?
Yeah, I'll go
earlier?
look for it. Absolutely.
Okay. Look at anyway, lots to think about. And then I had a question for Paul as my lead out from me into Paul, I guess, because he's next on the list. And when you gave your presentation last week on doing your timing period on your encoder pulses, how do you handle if your robot is on a slope and you're not giving it a speed and direction and it starts rolling backwards, let's say?
That would not be handled correctly.
Okay. I was just curious if you had done something to handle that.
No, there's no way to tell what direction it's turning in. And, you know, I think with...
If you have a quadrature encoder, you can tell.
Yeah, you're right. You're right. Get a quadrature encoder. A little difficult mechanically with this mowing robot. And the mowing robot has a big heavy motor and heavy gear train that it's just not going to roll backwards.
You can also use an IMU to tell.
Yeah, and that's the other one I was thinking about. But it was just one of the questions I had after watching the video, and I got a chance to ask. So that's it for me.
Okay. So I'll go next. And this is actually update for Pat. So you've been giving me all kinds of good ideas, Pat, and I appreciate it. In fact, I'm going to look into that SSD question. But the you mentioned last week a protocol that you're using for communication between your Arduino and the RPi, serial transfer. And I looked into that. I spent quite a few days studying it in some considerable depth and building some examples that use it. And so I wanted to report on that experience, because I don't know if you've tried it or how much you've used it, how much you've done with it. But I would say I started about 3 weeks probably ago, 2 weeks ago probably. I gave a demo of a different protocol based on something called serial transfer for communication between Pi and an ESP32 or Arduino code. And what packet, I'm sorry, I said serial transfer. I meant packet serial is what I demoed. But packet serial is really just a COBS encoder decoder. COBS being constant overhead byte stuffing, meaning you never get any 00 on the line except when it's a start byte. You have to wrap your own stuff around that to send it over the link and put in a header and a packet length and the CRC and all of that, which I was planning to do till you pointed me at serial transfer, which I'm glad you did, because serial transfer has most all of that stuff in it. So it actually is kind of turnkey from a point of view of transmitting data over serial link between the RPi and an ESP32. It even has callbacks on both the RPi side, which is done in Python, and the Arduino side done in Arduino. So I implemented an example using callbacks both on the Python side and the Arduino side, and I'm going to post a URL to the GitHub site. Let's see. I guess I started about 8:20.
Paul, are you posting to your site or to the GitHub site for the Pi serial transfer?
Posting to my site because what's in my site is examples. So specifically, the what I just posted in the chat is my GitHub repo with the Arduino code, and the path goes down into an example that has loopback with callbacks. So the Python side sends a couple of types of messages, a text string and a list down to the Arduino side. Callbacks on the Arduino side read the string and list out of the serial transfer object, turn them around, loop them back, and post them back to serial transfer, post them back to the link where the Pi serial transfer callbacks receive the looped back data. So it uses callbacks on the receive for both sides. And that was a little more difficult to get working than I expected. And it turns out, so now I'm just going to commend that to your viewing as a working example that is very Arduino-ish. It doesn't have any like free RTOS stuff in it. It's just pure Python on the Pi side and pure Arduino on the ESP side. But now I'm going to switch to offering an opinion on serial transfer. So compared to packet serial that I had been planning to use, it's a superset. It's a complete superset. Packet serial is only the COBS encoder and decoder. You have to wrap everything else around it. Serial transfer has the transmit side and the transmit object side, receive object side, and it puts in CRCs, issues error messages if CRCs don't compute, has callbacks. So it is a complete superset. However, it is, in my opinion, a relatively immature package. The guy who created it is a double E who lives in Virginia, it turns out. I looked on his GitHub homepage and he links to his YouTube page, and it turns out he's a Arduino flyer, Arduino RC model flyer. And so I guess he's done this protocol to talk over the link to Arduinos on the plane, and then published it. And so it's a little unclear. I filed 2 issues on it for what I feel are bugs. One is that it doesn't handle variable length data. So if you look in the example, there's an example for sending a string, but if you look at the receiver side depends on knowing the length of the string that's sent, which in general, you wouldn't know the length of a string that's going to be sent from one side to the other. So there's a workaround for that. You just publish put an object in that says how long the string is, then you put the string in, and then the receiver can pull the first object out. And if you use it in conjunction with callbacks, then you set the packet ID to string. That object gets a callback, and it knows it's a string, so it knows to pull a length object out, and then it knows how long the string is it should put out. So it's a workaround. There's a workaround. It's not difficult. The other bug was for a rather difficult to find situation involving callbacks on the Arduino side where the example they gave didn't work. And the reason it didn't work was because the available method is in the process of, so the serial transfer object holds a packet object, and the callback is called with inside packet before the available call has returned back up through serial transfer, and serial transfer doesn't have bytes read valid at the time the callback tries to use it. So it was a little bit tricky to debug, but maybe he might respond saying, well, I'll document a bit different environment, like the callbacks their environment is a little bit different than his examples. So anyway, these are just examples of how it's a brand new package. He feels like he just put the finishing touches on it. It looks to me like from the commit comments, but I don't think I think he's done the first 90%. I think to make it professional grade, he still has to do the remaining 90%, of which a fair bit is documentation. But nevertheless, I am going to continue using it because I looked at a comparison. I compared what I had done on top of packet serial with what he had, and decided he's got a lot more there. And so it's just better. It's just going to be better to use what he's got and build on top of it, and adapt. And maybe I'll offer some pull requests or something. I don't know how receptive he's going to be to maintaining it. So anyway, that's all I had, was just a update for you and anyone else who's interested in this sort of packetized UDP style of serial communication, and specifically relative to the packet serial and the serial transfer packages.
So that's one of my plans. If I'm going to reuse ROS for a robot, is I'm going to ignore the ROS serial, because I'm limited on an Arduino as to what I can fit in memory. So trying to fit on an Arduino Uno, getting a twist command for velocities, and then publishing back a little bit of sensor data plus some odometry data. I don't have enough memory in the Uno to do it. But
and it doesn't buy you much. It also doesn't buy you much. I mean, if you think about it, what does raw serial give you? Right? It lets you're going to have code on the Arduino, and you can change it and publish new information.
You're muted, Chris. Oh,
am I?
That was sorry.
Okay.
Senior
I
moment.
wouldn't be surprised, sometimes stuff doesn't work. So what it gives you really is, right, you can publish new information from the Arduino, and on the receiving end, nothing has to change. It just magically shows up.
Yeah.
But again, so that's convenient, but the way I'm doing it, so I'm publishing and spitting out new information from my Arduino type nodes, but then I have a receiving end of a serial on the other side that picks the data up, whether it's I2C, whether it's, serial, whichever way the data comes in. And then I publish it on the ROS.
Yeah, right? So that's what I was thinking of doing as well. So
I find it more flexible. Again, there's some elegance to ROS serial, but it just, at the end of the day, doesn't give you something that you can't reproduce in maybe a simpler way, and without getting, again, things even more complex than necessary in your Arduino code.
Yeah, I've got my Arduino code working the way it is over serial, over USB serial, and it seems to be working fairly well and very repeatable. And if I try to rewrite that, like I say, I have to go to a bigger processor to be able to publish odometry and other statistics.
Yeah, so you wouldn't have to change it at all. You just write some Python code on the other end
I've already got a Python routine written.
There you go.
All what I have to do is replace my MQTT stuff with ROS.
There you go.
Yeah. And to add to what you said, Chris, so I agree with what you said, that it doesn't, raw serial doesn't bring much. But to add to that, I think it actually brings a negative. And I was actually involved with raw serial. I did raw serial for embedded Linux over a network and contributed that. But I think what it brings is a dependency on a kind of like a round trip, a sort of a session oriented communication. And so if raw serial loses a packet, it may need to come back and try and retry, and that can have its own set of problems. And so I feel like it's the UDP model is more robust in terms of not being session oriented. Okay, that was it. On to who is next? Cooper.
Howdy. So this is my first time presenting. I'm going to be presenting a personal project and then a really quick update on the Iron Rain robot. I've been working on and off, let's say, for a couple months now on a robot arm. And let me just share. I've got a presentation here. So I had come up with just a basic mission statement. This is my older one, which was to create a 4 DOF arm with a turret, a shoulder, an elbow, and a wrist. I say on here, carry a good amount at the end effector. As you'll see later, I still don't have like a proper estimate of what I want the end effector to be able to hold. I want this to be like a really solid base. I want this to not look like a toy, and I want this to be like, again, a good test platform for just general work. And I need something that doesn't put me in debt. We'll get onto that later. So this was version 1. You can see that the CAD model's really rather basic. It was really early into my CAD kind of experience. You can see that it's a 4 DOF arm where you've got a wrist, an elbow. You've actually got a swivel on the first link there and a base. Now, I never got into production of most of those parts because I really quickly learned after printing this first link here that it is not a good idea to put the output shaft of the stepper motors I was using directly into 3D printed parts. Again, this is like my first time trying to build a robot by myself. I wouldn't have known. And now I know that the proper way is to do kind of captive nut or captive kind of a shaft set color. I don't know. What really the proper way is not to direct drive at all, but I learned that really fast. Oh, and the last part of this arm design was that it was cheap, which kept in line with my project statement. The Mark II, after I learned about the failure of putting the output shaft directly into 3D printed plastic, I moved on to belts. And I did this kind of instinctually, not on the basis that I realized that you're supposed to have at least some sort of intermediate stage between the output of the work provider, the motor, and the actual output shaft of the motor for motor health. So I actually created this design with belts. You can see right here. Does my mouse cursor show up?
Yes.
All right, cool. So you can see the base was the same design. It ran not directly into that arm. It had a little kind of uh, out section here where you'd have the output shaft coming out here, and you'd have a small belt going to a really large sprocket that is directly tied to this arm. You can see that large sprocket there. And I did only print those two parts because I, again, learned quite a bit from that failure. In that, you can kind of see, well, actually, here you can see later on the stage, this stepper motor right here. Yeah, I know, very good art. The stepper motor right here was put further down so that it would create less torque because these stepper motors I knew off the bat were really weak. Here's the one that I was using. It's scrapped from an old MakerBot 3D printer. I didn't realize just how weak they were without any form of proper gearbox until a little bit later. So, yeah, I kind of learned my lesson there. But at least I kind of had the foresight to put them a little bit lower to reduce stress on that shoulder there. And you can see that the same kind of technique where a small sprocket on the stepper motor was driving this big
Pulley.
yeah,
Call them
thank you,
pulleys. Yes.
pulleys, yeah, which was directly tied to this, so that it kind of created a system where I didn't necessarily need to worry about the direct connection between the motor and the arm. I could just kind of put it through this joint directly, if that makes any sense. The big issue with this design, and thank you to Mr. V for helping me figure this one out. If you can just take a guess as to why there might be an issue between this hashed section and this hashed section, as to why that ratio of timing belts, note these are GT2, GT3 timing belts, why that might be an issue. They're like at they weren't exactly this close, but it was pretty darn near this. So you can see that quite literally there was less than half of this like 16 tooth pulley that was being engaged with this larger
Yeah.
pulley.
Not enough teeth. Yeah.
So I don't have anything to show on this newer version, but I do have plans. I am going to definitely create a belt-based gearbox for the motors that I'm going to be using. Later on the list, you can see that I'm hopefully looking at going to brushless motors, as again I was looking to increase the beefiness of the arm, make sure that the end effector can actually hold quite a bit more weight than the stepper motors would be able to provide. And if I don't go for brushless, I'll go for NEMA 23s instead of the NEMA 17s that I was using. I would like to CNC as much as possible, so I'm not kind of, downgrading to plastic. I'm going to be using actually appropriate belts, the GT5 belts, I believe they're GT5 5mm. It's been a little bit since I've worked on this project proper.
So GT2 and GT3 are the belt profile from Gates. That's separate from the pitch. So I think you were using the 2mm pitch. We're using mostly the 3mm pitch on the Iron Rain robot, and I think we recommended you use the 5mm pitch on this heavier duty arm.
Yeah, and I've had quite a bit of success with the 5mm pitch. I with this brushless motor, this is the first one I got because of a separate project that I was working on with human scale forces. It's like a stupid little electric
Skateboard.
skateboard. Yeah. I use those GT timing or those GT5 the 5 millimeter timing belts on those, and I didn't have any torque issues there, even with 3D printed parts and just really sloppy uh, tightening of those belts because I'm still learning how to do that better.
Cooper, this may be something you've already addressed, but often in a case like the one you described, where the proximity of the timing belt pulleys is close enough that you don't get a good wrap around one or the other, the solution to that is to install idlers,
Yes.
or at least one idler. And then that idler is also how you tension the belt, so you kind of get 2 for 1 there.
Yeah, totally. On the skateboard that I'm working on, that obviously that worked. I'd say worked because it's kind of in pieces. It is getting a redesign with CNC plates, and I'm actually making it nice. I'm putting an idler in there that's totally in the works. I guess the issue with the previous one was that you can kind of see here the distances between the possible positions of this output shaft and the actual the actual position of where that pulley would be, right? That is so small that there was not a chance I could get an idler in there. And again, I didn't know idlers were even like a thing back then. So, but yeah, idlers are a very good idea in this context. I guess in the redesign, really. So a revision to this project statement would be that I'd like to keep with the 4 DOF requirement. You can always, I could make a higher degree of freedom robot arm, but that's just going to add complexity. And I mean, I've got a lot of projects that are on the back burner, so maybe I don't want to make this one too complex. Though I get that this is not a trivial task. This was originally going to be my senior engineering project at my high school, but they canned the engineering teacher, so we don't have an engineering class anymore.
It's not available.
Yeah, but just for personal, just for like I don't know, self-fulfillment maybe. We'll say that this project's for. Um Again, I still haven't figured out what specific kilogram like payload I guess you could call it at the end effector I want. I'd like to generate a number when I actually delve deeper into this project, see what's kind of available with the amount of money I'm willing to put in it. Oh, which leads me into the next point, which is I'm willing to put myself in a little bit of debt. Not really, obviously, but I'm willing to spend some money on this project. Is what I'm saying. I'm going to use what I already have. This chunky brushless motor and Flip Sky ESC that I've got. But since I'm doing 4 DOF, I'm probably going to look into also getting an O drive and maybe using a NEMA 23. Is it NEMA 23? You know what I'm talking about. For maybe like the wrist joint. And the final point is I know it may be just like funny, or it may seem flippant and funny, but looks cool. And I say this quite frankly because I've looked at all my past design iterations over the course of this night. I threw this presentation together tonight, if you'll excuse me on that. And it looks like a freshman's Fusion 360 project, which I mean, that's what it is, but I'd like it to look nice. Steam is what they're kind of getting us all into nowadays, with the art aspect in there. Especially if I'm be putting this in my room, I'd like to make it look nice. Anyways, I digress. My big question that I was looking to get answered tonight, other than well, yeah, or I guess the big thing I wanted to do tonight is ask a question, other than to introduce you to my project real quick, which is how do I fund this? I don't have a lot of expenses. I don't have a car, so I don't have to pay for gasoline. I don't have a partner, so I'm not spending money there. I don't have a proper source of income. I pick up odd jobs, but what are some, I guess, uh, financial tips on getting these kinds of parts like the O drive, which is stereotypically expensive, especially for a student. Um, yeah, I guess just what's some good ways of getting around the high cost.
Cooper, I have a comment on your look cool requirement, which is that, yes, 100%. I have a colleague that worked for the aircraft industry building things for the military. And I was talking to him one day, and he was talking about all the different requirements. And then when he got to the end, he said, and of course, we're selling these to generals, so they have to look mean. You know, when it's sitting there on the runway, it's got to look mean. They've got to go, oh, yeah. So that's actually not a peripheral requirement at all. It may actually be the requirement that gets you funding.
Interesting.
Hey,
Funding.
Kareem,
Yeah.
there was a robot arm at the makerspace. I don't know that anybody has claimed it. I wonder if he could use it if he wanted to.
That thing with the one with the chain drive?
I'm not certain if it had chain drive. It looked enclosed.
Yeah,
I think. Do you know what I'm talking about, Kareem?
I do, and I think anybody that wanted to use that should take it.
This is about just using something. I think it's about creating something, but I'll let Cooper
Well, you could take it apart, use the pieces.
No.
I don't know if they'd like you to do that.
Yeah.
Yeah. Definitely. I think Mr. V said it best. This is less of a project of having as more as making. It's about the journey, as Disney films would put it. At least in my eyes.
So cost comes, or scale comes with cost. They're associated. So what's the driving reason for having a larger scale version of this, other than it just making it seem more applicable to for something like that? Because you probably could have done it with your smaller set if you just scaled the whole thing down, and just didn't worry about having a hefty I don't remember how you said it, but some sort of hefty load that it could carry. What if it was just a key ring that it could move around or something like that? Does that just seem that gets us back into the toy territory or something like that?
Maybe a little bit. I mean, like, to be fair, I don't really have any concrete reason to not make it smaller, other than just I guess, a personal desire for it to have somebody maybe look at it and be like, "Whoa, that's cool." But
Well, you said the first
also,
stage on it was a slide, right? Go ahead.
Yeah, sorry. It would be good in the future if I do this now. This would be a very excellent platform for the future. Since I'm looking at going into this kind of stuff, it doesn't. It would seem to me as though it might be useful
For joining research teams and things like that. I noticed that you had a slide defined as your first stage. So was this like something meant to move cameras around or something like that?
I mean, that was a thought. I've quite gotten out of the filming scene, but it wouldn't be so wouldn't be such like a yes to answer your question, but also just because I was gonna have a picture. I didn't get to it in time of where it was gonna go. It's right above my desk. So I was also hoping to use it a little bit as just kind of like a helping hand.
bring you pencils or something. Okay.
This sounds really silly now that you've
It's all right. It's all right. I mean, it's okay, but it is kind of strange to start out with the project without defining what you want it to do, especially when that like bears directly on scale and cost. Yeah.
It could
So-
buy checkers or chess. I mean,
There
that's
you
what
go.
tend to use arms like that. And then it goes back to scale and cost. So one of the things we'd be able to ask is, do you have a 3D printer?
Mhm.
That would be one path I would go for your design. And it could be to then scale up into metal or whatever. After Cache, design the part, and then scale it up to cut metal with like a plasma cutter or whatever. If you wanted to go bigger and keep costs small first by 3D
Totally.
printing.
Oh, these parts that I had printed, or the parts that I had shown, I actually did print on my 3D printer here at my house. I'd show you, but my laptop right now is a jumbled mix of wires to try and get everything set up here.
And then, and then as I say, if you want, you have the 3D printer, so that's probably the best path. I was going to say, if not, wood's the cheaper material in that, and you can work with that. So it's a matter of how to keep costs down to do proof of concept and then work up from there.
Okay.
Cooper,
All right.
do you have a handy size heavy object that you'd like to move around? I can tell you from experience, and I'm sure you have the same experience, that, for example, a can of Coke is quite heavy for a small robot arm to pick up. So is an empty ceramic coffee cup. You might just pick an object and work backwards from there. Pick an object that you'd like to be able to manipulate. So I say, to be able to hold a Coke can out at arm's length, I mean, I can't do that for very long with my own arms. So most of the, when we look at hobby robots with hobby robot arms, they pick up paper cups and stuff, little Lego bricks and, no mass at all. But you might pick some real world object and start from there.
Okay. Yeah, I'll look into that. I don't want to take too much time because I do have to also get to the Iron Ring portion of the presentation. Shouldn't take too long. We're just going to show you it actually moves now. Mr. V, all right, let me stop sharing. I couldn't pull up the videos in time, so I was going to get Mr. V to pull those up and share those.
Okay.
But basically,
So what was the status on last Tuesday? You were showing the robot was in pieces or something? Or? You were working on it, right?
Yes, yeah.
Okay. So is my screen showing?
Yep.
Yeah.
All right. So this is the robot moving around outside in the snow on Thursday. Was it Thursday? Friday? Something like that.
Yeah, I believe so.
This is Ben driving it.
Are you sure that's not Northern Ontario?
Yeah, exactly. It's very unusual for Texas, but we had snow, so it seemed like it was propitious to try it out there. And you can see here it's having some problems
Is
climbing
battery
a
low
bank.
or something?
Oh, that's me in the video. Yeah. 7 volts.
That's
12-volt battery at 7 volts. So that was not a good choice. So struggling here. I think he's about to turn it around and drive it the other way. And yeah. So you can see they got it working with the differential and that swerve combined. So they figured out the vectors where they have matching. I don't think that this one shows the robot expanding though. But yeah, this is just robot tooling around. Some like all of those Mechanum robots that you see, and there's there's our typical failure mode. So and every single one of those videos, like we took a few of them, ends with the robot tipping over. And you'll notice that the outriggers are missing on here. They broke off very rapidly, so there was a redesign required. This video is even shorter, and this is just showing the robot doing its transfer function. So I don't know if you can see, but right here there is a snowball inside the gripper, and it's going to transfer it to this bucket. And that's all automated behaviors. And then it has to, push it out, and then like we didn't know where the dump control was, so it wasn't dumping that. But that was it. That's all we had to show on the video.
Gold star.
How do we get gold for that?
I think so.
Is that how it works?
Yeah, especially since it was out in the snow and fell over.
Yeah.
I could just push mine out the patio door if that'll get a gold star.
All right, we got a gold star right there.
Pat, you got to have yours get avalanched. Going down the driveway and the sidewall of the snow just coming down on it.
That was the other day. 6 inches of snow yesterday.
Yeah.
Good progress, guys.
I'll show you one more thing real quick. They're in the middle of trying to create new wheels for the robot. So those are those are like 8-inch wheels off of a rock climber rock crawler. They've designed a new version of the wheel made out of NinjaFlex TPU, and this is sort of what the design looks like. This is actually a fail. So these are each 3 separate prints that failed. Here's another one. Here's another one. Lots of failures on this. We have yet to produce an entire wheel. If once we get one, it'll actually take about 50 hours just to print the TPU portion of it. The interior, so that's the rigid hub. And their plan is to put a motor inside right there, so that because right now the motors are up on top, and that'll sort of reduce the center of gravity significantly. And so that requires some machining and aluminum, and so they're in progress with that. But yeah, it's taking a while to print those wheels, and we're having a lot of failures with that. But they stole this design from Rudd sent out a video a few weeks ago of some university rover teams, and one of them in Australia had something that looked a little bit like this, where the internal structural profile is sort of like Gothic arches interleaved, and it seems promising. Maybe a little too stiff, so they could just like decrease the thickness of these arch elements, and end up, hopefully they'll find a reasonable ratio or a reasonable stiffness and compliance match.
Kareem, what is the failure mode? I mean, why are they?
It's all about our 3D printer. It's a lot of different things. I think that the heat on it, the heat control of it on it is starting to fail. And we also had these giant, because this is large, right? It requires a half a kilogram of filament to print one of these. And so we went with these 2 kilogram spools, and they're super heavy and create a lot of tension. And I think the extruder was having trouble pulling the filament off of it as well. So some of these are just like foamy messes, like they have almost no strength, and they just Up close, they just look like there's holes all in them. I don't know if we
Swiss
can
cheese.
focus on that. It's like cheese, yeah. So lots of different failure modes. Right now, we've got one on that's been on there for it's at 50%. So in fact, it's about as far as this one, but totally Swiss cheese top, and that one's looking okay. The one that's on the printer right now. So keeping our fingers crossed, and maybe it'll come out this time.
How many wheels do you need? How many tires?
Well, it's 3 you saw on that robot. So at the very least, they need 1, right? So the whole problem with the robot, I can actually sitting right here, so maybe I can show you real quick. Can you see how flat that wheel is down there? I can't quite pull it quite close enough.
Yeah, it doesn't really come across on video.
Yeah, can't really tell. But these wheels flatten out an awful lot, and that's because of the load of this swerve frame head plus the entire arm up here.
Yeah.
And it's just more than these were designed for. These are designed for very light RC vehicles, and even though they like added more foam on the inside, it's just whole idea is that hopefully this will carry that load a lot better and still have the compliance needed to get over the barriers.
What if you use something like that? You said you put in additional foam, stuff that expands, that expando foam.
Well, that stuff is pretty rigid, and once you compress it, it fails. You're talking about the kind used for insulation.
Yeah,
You
that's
buy
what
at
I was
Home
thinking.
Depot.
Mhm.
Yeah, once you crush it, it's got no resilience left. We have another different kind of open foam that is like used a lot of in a lot of packing, and so they created an internal layer of that with an external layer of more of softer compliant foam. But the way they did that was sort of just hacking at it with scissors and stuff, and they should have probably put it on the CNC and created a nice consistent structure for it, because there's a lot of variability in that back wheel. But when they get desperate, I'm sure they'll either do that or maybe they'll get this thing figured out.
I know you guys, you do a lot of printing, so you know all that, but I was just saying that for TPU, you getting the, what is it, the suck back?
Yeah, the retract
you
can be
got
difficult.
it. You can't. I couldn't do. I had to not use retract. Totally. Now it gives you a lot of strings, but with no retract, I was able to print without any too much trouble. I mean, that's my printer. Each printer depends on how the extruder is designed. Mine's what I think they call it a Mark III printer, a Mark III extruder. So I mean, it's pretty basic extruder.
Is it direct drive or Bowden?
Mine is actually a direct drive, but it has it's not a geared direct drive. Okay, you know how like on the old 3mm filament, you had a big gear that pushed it down. That's what I'd call a direct drive, but it's geared direct drive. Mine just has, a little sprocket on the end of the stepper shaft, and it goes from there. So it's just what do they call those things?
We're still using the 3mm filament, and
okay. Yeah.
Because that is one thing that is usually more successful with TPU is the thicker filament.
Yeah. Well, I could see, like I say, I was able to get some really nice prints. I just couldn't have it retracting at all. So I mean that's the one that seemed to be the single most important parameter on that I had to set.
That's not. I'm pretty sure retract isn't the failure mode that we're dealing with.
Okay.
Yeah, I'm thinking it was more temperature control, and then the pull strength of resistance of that big spool. Right now, it's looking promising. In fact, the previous print looked promising, but I threw some bearings inside the 2 kilogram spool to make it turn easier, and but didn't really like control how it was retained to the arm that it was mounted on. And it ended up falling off to the side overnight, and and you know, then it started printing air for a while. So, but at least the actual print quality looked right for while it was engaged. So hopefully we figured that out, and I think that they are going to have to redesign it to be a little bit more compliant than this one's looking right now. Who is next? Way up.
Next.
Chris is next.
Yes. All right. I have two things loosely related, but the first topic is just a couple improvements I've made to my workflow and tooling and in sort of convenience of testing my robot. Just a couple of things I wanted to show there. And then the other topic is the obstacle avoidance that I've been working on as a implemented as a behavior with an arbitrator, etc. So first on tooling, I mean, because I talked last time a little bit about how and I showed how it's taking advantage of the whole parameter setting UI that ROS gives you. So along those lines, I've made a couple more improvements to my workflow that others might find useful or maybe already know. So one thing, when you're dealing with ROS, we talked about what flavor of Linux to run on the Pi. Similarly, you're gonna need Linux on your desktop PC, primarily because, or laptop or whatever, on your big computer, primarily because you're gonna want to run the visualization tools actually on your PC, not on the Pi. And to do that, you're gonna need Linux. It gets really painful to do that in Windows, but I prefer Windows, so I've been trying out different combinations of dual booting my laptop into Windows and then into Linux and back into Windows. That was too painful. I've been a long-term VirtualBox user, originally VMware, and then for the longest time I've been using VirtualBox. And then recently I took another look again at VMware, and I have to say, hands down, it just has much, much better performance than VirtualBox. So I'm just mentioning that if anybody else is in a situation where you need to run Linux on the Windows, and with all these, there's other options too, Windows subsystem for Linux, etc. But VMware, I'm finding now is really hands down the best in terms of graphics performance in particular, right? So because again, in ROS, you want to run these visualization tools, not these visualization tools. They're gonna want OpenGL, they want 3D acceleration, and I've been finding VirtualBox to just not deliver at all in that regard, and VMware to be about a factor 10 faster than VirtualBox when it comes to graphics. So that's one thing. So again, there's so many different ways to do this, and but for anybody else who finds themselves, if you find yourself in a situation where you need to make a decision between VirtualBox and VMware, go for VMware. Okay, so that's the takeaway there. Then the other thing I was trying to figure out how to do, and again, this has nothing so much to do with ROS in particular, but anybody working, in a Linux type environment, whether it's SSHing into the Pi or what have you, in running all these different Python programs, you tend to have a need to see the output from all your different programs. And I've been trying to find a way to make the most of my screen real estate. So one utility I then ended up finding is called Terminator. which is really just a terminal, command line, a terminal emulator that lets you split, screens into different, horizontal and vertical slices without adding a ton of, screen real estate overhead, right? There is just a little bit of a header and there's a scroll bar, but what you end up getting is as many little command prompts as you kind of need, right, to see your output. And again, it's to me at least real important because, in similar to what Pat was describing, right, we were talking about, you got all these different Python apps or behaviors or whatever, right, and you don't need to see the output. So this is one way to do it without cluttering up your screen. And anything that has tabs to it is great, but you can't see it at the same time. And so this is real great for getting lots of different command prompts. Some of them may just have very little output. Okay, so keep that in mind. If you need something like this, Terminator is the keyword here for you to remember.
Chris, are you able to launch that with the split screens, or do you have to go in and manually split the screen as you go?
Good question. I haven't closed this down since I fired this up. It's just been running, and I've been just suspending my VMware machine. So it's, again, another nice feature there of VMware. So I think it remembers it. I don't know if you can tell it. I haven't looked at all the user manuals. So I hope it remembers my configuration.
Yeah, the reason I'm asking, do you have to launch originally each application in the separate window?
Yeah, so originally when it starts out, it's just like one command prompt, and then you do like right click. Sorry, I'm in the wrong screen. You do like right click, hey, split me this into two things.
Yep.
And then I'm gonna get another one. I just don't remember. I just don't remember if it remembers my configuration. But in terms of then launching all my stuff that I need to launch, well, that's another sort of thing that I need to still improve a little bit. I have made some improvements there. In the RAWs, you have these, what they call a launch file. I'm not a big fan of it. I've started to put a couple scripts together. One where I just kick everything off that I always need, right? I need to run the RAWs core. I need to fire up the LiDAR, set some initial motor speed of the LiDAR. There's a couple things that I can fire up that I don't need to usually modify, and that just sit there in the background. So I actually did that because it saves me actually a lot of time on startup. But then these other little programs that I have running here, I just need to sort of start them manually. I haven't found a way to sort of pull up this Terminator matrix thing here and then have the right program start automatically. And part of it is, again, this is happening on my virtual machine, but in each one of these little command prompts, keep in mind that I'm actually SSH'd into my Pi, right? Because all the work happens on the Pi, except for the visualization, which I'll pull up, but you've seen it before. But all these little command prompts, and you see here, Pi at PyMate, right? This is all happening on the Pi. So I'm just getting
you've had to
command
launch,
prompt into the Pi.
You've had to launch your Pi terminal essentially 9 times here?
So,
or when you
again,
split it,
if I power cycle my Pi and keep this running, I'm gonna get kicked out of each one of these guys here, and I'm gonna get kicked back into my VM. Okay, now I'm back in my VM. So that's what happens when I turn off my Pi at night, right? So next day, right, I would get back in. I'll just SSH back into my Pi, okay? And there's again one other helper script I'm running to elevate the priority. So there's a couple things like that. And now off we go, right? So yes, so it's still it still takes a couple manual steps, right? I'm not really trying to make it so that everything fires up when I turn the Pi on, right? Because most of the time I'm just experimenting with something, right? So I'm not at a point where I can flip the switch on my robot and it just, starts doing what it's doing. I'm not there yet. At some point, that's another thing to sort of put in place. But right now, I'm just looking for getting everything going as quickly as possible and then making it easier to change things and to diagnose things. So it still takes some manual steps for sure. But this thing is definitely helping with making the most of my screen real estate. The other thing, again, I'll make this comment again because I've made it many times before. If you want to make sure that the important things get done in a timely fashion on your Pi, you do have to keep an eye on priorities. And I run all my robot stuff. It's sort of elevated priority. If I sort here, this is all low-level driver stuff that I don't want to interfere with, but anything here that shows up as -4, which is just a weird way of saying it's high priority, is one or the other of my Python scripts running on the RAWs, and that helps ensure that things like Visual Studio Code, which is also going on here in the background, right? Me editing files over a remote connection, is not interfering with the timing of my robot control code, right? So again, I've mentioned it many times before. People often complain, okay, Linux, you can't guarantee the timing, and yeah, it's true and it's not true. You just got to real pay attention to your priorities and take advantage of the features are there. And I just really crank up the priority of all my robot stuff, and then I really don't have any issues. And so I'm just monitoring things here in one of these terminal things. You can see I'm using about, on average, 15-20% of the CPU or so. Just helps me catch anything weird going on. Again, so this is just another little workflow thing I wanted to pop up there for people who want to do something similar. Then the next thing, and that now gets a little bit into, well, again, it's still not raw specific, but I showed last time, the how helpful it is to be able to change parameters, right? Because a lot of times that's what we do, right? So that's great. I got that. I showed that. But then a lot of times you do end up changing the code, right? You're changing the logic. You're not just tweaking some acceleration or deceleration parameter or some threshold, but you're actually changing the logic, right? And I wanted a more convenient way of doing that. And because again, what you end up having to do is, right, you hit your Control-C, right? Then you go edit your file and you save it, and then you go back in here, right? And you rerun it. Okay, you can actually automate that. So I found a real easy way of basically automatically restarting the Python script when it's changed. Okay, and just to illustrate that, right? So in one of my windows, I'm running my arbitrator logic here, and that's the file I have open here in the editor. Okay, and with just a few lines of Python code, basically on startup, you find out, well, when was this file last modified? Okay, and then while you're running, you basically take a look at, okay, has the file modification time changed? If so, well, do whatever is appropriate in this context to kind of restart. Okay, and, you got to do a few things to clean things up. Got to add a little bit of delay. This Visual Studio is still in the process of saving. And then when everything is ready to go, you kind of just say, all right, just restart this thing that, with the same arguments. Okay, so let me illustrate that. again, if you look on the left, this is where this arbitrator is running right now. And if I just hit save here without even making a change, boom, it's gonna just say restarting, and there it goes. I mean, so it saves me, it saves me a few seconds. It's not a big deal, but these are little things. It just makes life more convenient when you in experimentation kind of mode, and you're tweaking your code, and all you want to see is the effect of the change you just made. You just make the change, save it, and it just instantly, your code instantly sort of is sort of updating. And so again, it's just one of these little time savers that I started introducing in all of my scripts. The other thing I started doing, and that's where it gets a bit into RAWs and some of the annoyances, when you are running the visualization on another PC. And so again, I don't think there's any other way you want to do it. You want to run these visualization tools on a more powerful computer to not bog down your Pi. But especially with this RViz tool, it just a lot of times gets confused, especially when you are restarting your individual applications, and then data goes away, data comes back. Sometimes it figures it out. Sometimes, you got to hit this reset button and maybe that's good enough. And well, this made it worse, right? So now it's confused. All the data is out there. It's all getting published. But RViz has a real hard time kind of resynchronizing, or whatever you want to call it, right? And so what I found necessary is to restart it. So again, to make this as the least painful as possible, I have a little loop running somewhere, maybe in one of these terminals. Yeah, it's probably one of these, where I have a little while loop running. Okay. And I'm just running RViz. And if it were to quit for whatever reason, I'm just going to relaunch it. And it usually doesn't crash or anything, but I'm going to quit it, right? So again, to recover from whatever happened here, because I was making too many changes, data went away for too long, RViz got confused, I'm just going to close it. And it's going to restart on its own. So again, it's another little convenience thing that just, instead of me getting annoyed by having to find the right terminal window to restart it myself manually, right? I just let this little loop take care of it. So again, little things here and there just make the workflow more efficient. So that's that. So those are kind of little efficiency things I've worked on. And then in terms of the actual obstacle avoidance behavior, I did work on that as well. And I've played around with choice of my virtual range sensors that I'm using, and I've just displaying the ones right now that I'm using. So in the end, I've concluded that to detect if something's right in front, I want to just look at that one primarily. It's a 30-degree field of view, and then this one for left and this one for right. What I'm trying to say is, rather than go even further out, I'm keeping it pretty much in this. If you think about it, this is actually a 90-degree. This is actually a 90-degree total field of view right now. If you orient it just right, it becomes a little bit more obvious, right? It's a 90-degree field of view, 3 times 30 degrees. So for where I'm at with my logic, for looking at whether something is in front or whether I'm approaching a wall, at some angle, I found that these are the best sensors to look at. There'll be other situations where I need to look at more side-facing, based on Dave's suggestions last week, but I haven't gotten there yet. So that's one takeaway here. Look at just these sensors. And then it is, minus the navigation part and integrating that, the obstacle avoidance is working reasonably well. So let me just show that. How do I show that? I think I just click here. Yeah, so I don't know if you can see that now. You may have to pin my camera view. So what's going on here is I have one behavior that's just driving the robot straight ahead, just forward. I'm not steering it, okay? I'm just telling it go straight. And then the obstacle avoidance behavior kicks in as needed, which is, well, actually 80% of the time. If you think about it, 80% of the time here, we are actually, avoiding some obstacle. And the minority of the time, we are just going straight. So it's really just two behaviors right now that my arbitrator is arbitrating between, and joystick, and I'm just and occasionally it escapes. So the obstacle avoidance is
good boy.
Is working reasonably well. I still have to.
That's some kind of star right there, isn't it? Isn't that some kind of a star?
Yeah.
Yeah, that's a star.
Absolutely.
Thank you. So I still have to implement one of Dave's pointers there, which has to do really with how the behavior interacts with the navigation, with the waypoint navigation, right? And that's the deal where, well, if I've just cleared the obstacle and my waypoint navigation wants to now make me turn towards the target, it may be too early to turn, right? I have to there's some interaction between those behaviors that I have to modify the waypoint navigation for. I know what to do, I just haven't done that yet. So hopefully that'll work out. Now, one thing I wanted to ask Dave, so one thing I didn't like about this whole arbitration-based approach, and again, I may have mentioned that recently, it's the first time I'm doing it in this fashion with explicitly arbitrating. In the past, I've done something different, just combination of state machines, but no explicit arbitrator. And I'm finding that there's sort of one use case that I'm not able to accommodate with this, right? Because the arbitration, it's like an all or nothing, right? So it's either you avoid behavior is active, right, and wants to control the robot, both linear velocity and angular, or some other lower level behavior is active, right, or even lower level, right? Whichever one is active controls linear velocity and rotation, right? Now, the problem I see is, or the limitation of that is, right, and if you don't explicitly do it that way, if you kind of do something else a bit more, I don't know what to call it, but what I've done in the past is, in a situation where I have an obstacle avoidance logic of some sort, and I have something else that, whether it's interactive control or something else, what I was doing in the past usually just intuitively is, okay, I have this obstacle avoidance logic, but I don't really want it to take over control just yet. But at the same time, I know I'm approaching a wall in front of me. So what I want to do is I just want to slow down. I just want to maybe impose some speed limit. I don't want to take the steering wheel away yet from the other behavior. I just want to impose some speed limit, right? Anytime you get close to an obstacle, I just basically slow down the robot without taking over the steering wheel just yet. Now, once I cross maybe another threshold, right, then the obstacle avoidance logic would kick in all the way and then actually actively steer away. But with the arbitration-based approach, I don't know how to do that, right? Because again, it's either the obstacle avoidance is in charge of all the velocities, or somebody else is in charge of all the velocities. But I can't blend those together. That's not how the arbitration approach works. It's either or, right? Not some blending. And again, in the past, I found myself just doing something that's a bit more of a blending of the velocities, where I just, like I said, I slow something down. I don't yet steer, but then once I get too close, that's when I start steering away, things like that.
Well,
So
I think,
any thoughts on that?
Chris, I think what what it sounds like is you don't have the correct distance limits for your obstacle avoidance. A sensor can provide inputs to multiple arbitration tasks. I mean, it doesn't all have to, my sensor sees something, I'm going to go into obstacle avoidance. It doesn't have to do that. You can say, okay, when I get, 6 inches from it, I'm now in, I think Dave calls it close, but whatever, it's now I'm in, I definitely don't want to hit this stuff. So now that thing comes in, because if you think about it, something like obstacle avoidance, I mean, you really don't want to hit things, generally speaking. So if it kicks in, it means you really don't want to hit something. So it should kick in when you've reached that point where you say, I don't really want to hit something. Not necessarily, if you want to slow down ahead of time, that could be a different portion of the sensor range.
Yeah, okay. But how do you do that slowing down ahead of time, right? Who does that? I don't want
Dave does it by assigning each task a rotation and a slew. Okay.
Let me speak for myself, Doug.
Okay, go ahead, David. Wait a minute, David. Are you muted? Go ahead.
Chris, to begin with, let me just be sure I understand what your desired behavior would be. So you're driving along, and you're driving, I guess, in a straight line, and the sensor sees something, and you'd like to slow down but not turn. But then as you get closer, you'd like to turn. Is
exactly.
Is that a good description? Okay.
Exactly. It's like I want to impose a speed limit, right? I want the navigate behavior to still let it do its thing, and maybe.
Well, now that was my question. That was my question. Should it continue driving in a straight line? That's why I asked that. I won't go into. We talked last week or week before last about how you can use the the slew rate generators in order to avoid what you're talking about, which is basically an abrupt shift where it's an either or. The slew rate generators allow you to blend the two together, but we can go into that later. I think we covered that pretty well last week. But the other is that the given behavior can have more than one band. You may remember when I showed the wall following, it said if you're too close to the wall, you turn gently away. If you're too far away, you turn gently toward. If you're way too far away, you turn sharply toward. So there's more than one behavior in that given set. Let me, hang on, let me see if I can find something here. There we go. Let me present. How do I present? Present now. My entire screen. Am I presenting?
Yep.
Okay, this is the IR behavior that I talked about in the talk. And just starting at the top there, we're going to read the IR sensor, and it's going to give us a left or a right or a center. And so we ignore that. Move on down to where there's a switch based on that detect. So there's actually 3 separate behaviors here. One behavior says I see something on the left, but I don't see something right or center. The next behavior says I see something on the right, but I don't see something left or center. And the last one says I see something center or center plus left or center plus right or center plus left and right, or even left and right without center. Basically everything else. Yep. And they each have slightly different behaviors. So suppose that center behavior, which slows the velocity to 0 and keeps rotating, suppose it didn't do anything with the rotation. If, as I say, if it kept going in a straight line, then you could have, if I understand the question you're asking, you could have that broken up into two different behaviors. And the first one says, if I'm, further than 20 inches, all I do is slow down. But if I'm closer than 20 inches, I slow down and I also turn. So you can have in a given behavior, it can be broken up into segments that behave in different ways. Does that approach what it is you're asking? Have I misunderstood what you're asking?
Well, I think I'm actually sort of in terms of how I'm using my three senses in front. I think I'm doing exactly what you're doing there, but I still don't see how you can. Let me give you a specific example. Let's say the Waypoint Navigation, let's say it's already driving on an arc, right? Because it's trying to adjust its bearing. And I want to let it do that, right? I don't want to interfere with that. I just want to slow it down.
Okay, when you say I don't want to interfere with that, but you do want to interfere with that.
Well, I do, but the reason I say I want to just slow it down is, right, because in the end, what I want to get is I want to get smooth movements, right? I don't want to get too close to the obstacle and then make a sudden turn or a sudden stop. I want to get to a point where everything is really smooth, whilst I still want to be able to move relatively fast most of the time, and start slowing down as needed, right? That's again sort of an approach I've used in the past, where I was just slowing things down, but another behavior was really in charge of the steering, right? It's my obstacle avoidance behavior was just imposing a speed limit, but otherwise didn't interfere with the steering just yet, right? Until we get way too close.
I think there are two ways to approach that occur to me without thinking about this any more carefully. And one is to use, as I said, if you use the slew rate limiters, that blends one behavior into another, so that you don't have abrupt transitions from one behavior to another. So if that's what you're trying to get, then that's one way to do it. The other is, if you're driving in a certain maneuver, this is what Doug was saying. There's no rule that says that sensors can only be used by one behavior. And I think I mentioned last week that my navigation behavior also uses the side-looking sensors to keep from running into things. So there's no reason at all that the navigation behavior couldn't also use the forward-looking IR in order to control its speed. It would still get subsumed when it got close enough, because the IR would say, well, you don't get to run it anymore. You're about to run us into something. But the navigation itself can use other sensors to determine what it's doing.
Maybe, now that you say it, I mean, that's, I guess, in a way what I was doing in the past without the explicit arbitration. So maybe that's the right way to think of it. Have the Waypoint Navigation also use those sensors, including forward looking, right? I was going to add that the side facing, because, I have to, to cover the corner case where we need to get all the way around the obstacle. But you're right, maybe just do that, have the navigate also look in front, and let it, it'll impose a speed limit on itself if there's something, that looks like it's going to be in our way. Just start slowing down a little bit, so that the avoid behavior then maybe doesn't have to kick in at all, right?
Yeah.
And maybe becomes a smoother operation overall.
And the avoid behavior might say, the navigation behavior says, if I see anything 20 inches out, I'm going to start slowing down, and I'll slow all the way down to 0. But I never get to do that because the avoidance behavior, when I get within 10 inches, it sees it and it takes over. So the navigation's not controlling it anymore.
All right.
So the only place I do, well, there's a couple of places where I do that. I mentioned that the navigation reads the side-looking detectors. The wall following, the perimeter following, is actually a pretty complex behavior, because it doesn't just use those two side-looking it depends on the rest of the navigation, the avoidance behavior working. So if you turn too sharply, the front-looking sensors see it. You're not wall following anymore, and they'll push you away, and so forth. So it's a combination of those all working together. Now, in that case, the front-looking just subsume the side-looking. The side-looking, once again, if you're going to run me into something, you don't get to control the robot anymore. But anyway, that's a couple of different ways to do it. I do think the blending of the behaviors can be done in the way the behaviors, they don't have to suddenly go to a certain value. They can slew to that value. And if they are, go ahead.
Yes, so that's another improvement I made. Actually, I didn't have that capability last week. So I added that just like you're doing it. I literally have the same slew function, and I've added it to the different behaviors to do that. But still, if I'm slow, I still have to decide what my target is for slewing it, right? I'm still taking over the steering in a way. I'm doing it more smoothly, right? But just because I'm slewing it, I'm still taking over. I'm still taking away the steering wheel from another behavior. But you're right. It achieves sort of, again, my overall goal is to go as fast as possible when that's safe to do so. And at other times, avoid in a fashion that's as smooth as possible. Don't make sharp maneuvers, sharp stops, sudden, I want it to be as smooth as possible, which is easy to do if you go slow, right? If I'm going slow, in the video I showed, I was going very slow. So it's looking pretty decent there because I was going so slow. But once I speed it up, things get a little bit more robotic, and that's, I'm trying to make the motions less robotic, even when I'm going fast. And that's why I want to be able to slow down, earlier and not wait to sort of the last moment to sort of then suddenly, make a hard turn.
I
I
wonder.
love how you're
Oh.
robotic.
To prevent the robot from looking too robotic. I will say that on the RCAT robot that I've done most of these demonstrations on, it has IR avoidance sensors, and it also has the sonar, and the sonar can see out considerably further. So the way that just evolved over time is that the IR sensors are actually quite sharp. They turn at quite sharp angles, but that's only because if the IR sensor sees something, it means you've gotten really close to it compared to the sonar. Because the sonar can see things further away, say 6 or 8 or 10 feet. That means a little tiny correction is all that's needed to avoid an object, 10 feet away. Turn half a degree and we're now not going to hit it anymore. So the reasoning is that as long as it's under control of the sonar turn quite smoothly. They don't turn very sharp. And those are very graceful, nice arcs, And then if you get up close to something, that means the sonar probably screwed up. You shouldn't have gotten up in there. And you probably need to turn sharply and quickly to avoid collisions. So there's actually two different behaviors that have different slew rates and rates of turn. And for the most part, the sonar rules because it sees things far enough away that it avoids them before the IR ever gets close enough. And the IR are quite angular.
I do wonder if you could, in theory, and I could be daft in saying this, if you could provide a priority value almost to give some interpolation between the two. I guess when you're handing off the velocities for your motors, I guess with the arbitrator setup, if you were to assign like a priority variable based on, I'd imagine, a collection of the distance sensor inputs. You wouldn't obviously just be looking at one of them. You could, in theory, weight the values of the different inputs from the two different functions. And again, to maybe interpolate, though a separate interpolate or in separate interpolation between the two different speeds that are being suggested, like an outside one might be something to look at. That might be that slew rate.
What I was thinking of doing actually is I mean something similar maybe, but it's really the fact that output of each behavior is like a tuple of linear velocity and angular velocity. In I treat them as one. If the highest priority behavior is in control, it's gonna sort of force its output onto the motors. But if I were to just decouple linear from angular velocity, and if I had a way of saying, all right, I'm a high priority behavior, but you know what? I don't care about our current angular velocity. I just care about our linear velocity. And I'm just going to put out a desired linear velocity value. And I'm just going to let the arbitrator know that that's all I'm trying to control. Right?
I have a function like that, Chris. It runs at a slightly different level, but when the robot bumps into something, that's the highest priority behavior. So it backs up and rotates and drives forward a little bit and releases control. But also it alone can control the global top speed. And so even after it emerges from that back up, rotate, drive forward, it has lowered the global top speed to half speed. And so even though it's not controlling the robot anymore, it's released the arbitration. Anybody else that's controlling the robot is using that global top speed to know how fast to run. So everybody has to run slowly for a couple of seconds. It's just the robot says, if you ran into something, I'm not going to run fast until we've gone for a while without hitting something else. Okay. So everyone reads that global top velocity. And other than me, the bumper behavior is the only thing that's allowed to vary that. And so what it'll do is after it finishes and releases control, it sets a little timer. I think it runs for about a second and a half or 2 seconds. And when that timer is over, it returns the global velocity value to its original full value. But so that basically is a way of making everybody slow down because without going through the subsumption arbitrator. Because
that's another possible approach. Yeah. Good. Thank you. Some good ideas.
Well, you get not only a gold star and a black star as well, but you said, I have this function that I didn't have working last week. And I'm just like, I so wish I could say that sentence.
I'd like to offer this, Chris, because Terminator is great. And the way that you save your window configurations is right-click on any of the windows, any of the panes, and select preferences, and then when in the preferences dialog, go to layouts, and then you can add a layout which will capture the current layout, and you can rename it to whatever you want. And if you pull up a new instance of Terminator, Alt-L will launch a layout launcher, which will list your saved layouts, and then you can just double click it or click it and launch.
Perfect. I just did that.
The other point to just address your issue of RViz and needing to close it and relaunch it, and certainly what you're doing is fine, works good. But perhaps a more conventional approach is to make a launch file called something like display.launch. Then you just run ROS launch your project display.launch, and you get a new window, and then you can close it, relaunch it. Kind of do it manually as you wish.
Yeah, I mean, I use launch files in a couple cases, but I just don't see a ton of value in launch files. I find them way too convoluted, especially the ones that come with the examples. It's like, oh yeah, you got this launch file and it's pulling something else in from over here, which pulls in yet another file from over there, which pulls in another file from over there. And in the end, I don't know what the heck is going on, right? Again, that's when people complain about the complexity of RAWs, is because sometimes even the examples that are given and the features that are there are really meant for some real complex robot, right? With lots of manipulators and lots of things and lots of sensors. But you know, when you're dealing with a much simpler robot, there are features there, mechanisms that you really don't need to take advantage of. You're just making your life more complicated, but trying to take advantage of some of this. So, you know, so it's I'm not finding much use for it. I just write a simple shell script, start this, done.
I would encourage you to read the chapter in the Gentle Introduction to ROS on launch files, because it's really good and they are a really powerful way of not having to do 9 windows where you do up arrow to log into your RPi 9 times. And instead,
well, it won't solve that problem, right? Because I still want the output from all my 9 windows.
well,
right?
so the more usual way to do that is to use ROS console and send your output out to a console, and then you use Swiri console, and Swiri console is great because it has SWRI _ console.
Yeah.
You can select a different node and look at what its outputs are.
Just too many features there to learn. That's the thing, right? Again, that's the thing that people can get overwhelmed with RAWs, because there's so much there. A lot of it is there for a good reason, but you don't have to use it, and you can quickly get stuck, you know, going up that learning curve, because you feel like, oh, I gotta really master this launch file thing, and I gotta all this, how it's managing the console output. It's all great stuff, but it's a layer of complexity after complexity, and then you get turned off, right? Oh, it's I'm never going to get my arms around it. So I'm trying to stay away from as many bells and whistles as I can stay away from, right? It's that's kind of my approach. There's only so much I can learn. So anybody else, like Pat, right? If he's still on, you know, he's trying to avoid getting into RAWs, but now thinking again about getting into, I think the key to success is to just find out what are the features you really need, right? And not assume that you have to take advantage of all the things that RAWs can do, because that becomes overwhelming very quickly.
Yeah, so I agree that I'm not looking to take advantage of the path planning and navigation on that sort of way, and you know, to try to keep going by David's example for navigating to a waypoint. But being able to use the message bus in the background is a huge bonus to trying to share the processor utilization instead of loading up one core completely.
Well, Chris, isn't that basically what you're doing? As I have understood your descriptions in the last month or so, that the real base piece of RAWs that you're using is the publish subscribe data transport.
Yep, it's the data transfer, because that allows me to use different Python programs running in all the cores and then exchanging the information. With that, right, with the data transfer implied in that comes the standard data types or message types, right? So there's a standardized way of representing certain information. You don't want to invent your own thing, right? Again, sometimes it's a bit more complex than necessary for a simple use case, but that's one area where it's important to stick to the standard data types. Don't invent your own data structure just for the sake of keeping it simple, because then you break a lot of, then that, you know, it makes your life harder in RAWs in a way. So you get those standard data types, right? So I'm using those. and you get the tools, right? Those are really the three pieces of ROS that right now at least I'm using. And then the next step is, well, things like the navigation stack, right? But that's a big animal to sort of figure out how to make it work well on your robot. That's the hard piece. It's not hard to make it work. It's just hard to make it work well, because it's a big black box and you just don't know what's in it. And so, but you're right. It's the communication, it's the data types, it's
And
the
then being able to
visualization
log.
tools that I'm using.
Pat,
I would add one more, a little comment to your earlier. Basically, if I go back some years, the path I went is very much like what you described earlier today, which is that I had a default behavior which was to drive straight ahead, and then I learned how to avoid objects. And then when I added navigation to that, it turned out that simple approach was too simple, because that assumed you were driving in a straight line. So when you avoided an object, you got away from it. But if you're running navigation, it's now trying to turn and steer back in a certain direction. And so it required a little more sophistication in how the behavior, the avoidance behaviors behave.
Pat, for the second time tonight, you said you don't want everything to run on one core. What is it that you are doing that's making everything run on one core?
No, see, that's just Python doing its thing for you, right? Because if you have, let's say, a single giant Python application, you cram all your logic all into one flat Python file. You could keep it real simple. You could take David's C code, convert it to Python, right, and have it in there. It'll all be very simple and clean. But Python, even with its multi-threading, right, it doesn't actually have proper multi-threading. It doesn't take advantage of all the cores you have on a multi-core processor. And then once you get into Python multi-processing again, then suddenly you need to do inter-process communication in some fashion. Right now it gets complicated, and that's the path that Pat went down, figure out how to do that, and but it's all because of Python, really.
But if you're using inter-process communication, then the OS should be distributing the processes across all the cores.
Oh yeah, I mean, if you have a single Python application that has multiple threads, that's not going to automatically happen on multiple cores. Okay. The moment you have multiple Python applications, you don't have to worry about it.
Yeah,
the OS is going to.
That's the real answer to Pat's question. It's not the introduction of a particular flavor of IPC. It's the splitting of his app into multiple processes that will then run across all of the cores.
Right. He has done that, I believe. He has done that. He just now needs to share all the information.
Okay. Thanks.
Yeah, that's where my problem is coming in, is the sharing of the info, because the only other way to do it is to launch everything from a main Python program, whether you spin it off in a multi-process or if you spin it off into a thread. But the only way to do it, and then the way Python works, is it'll try to put everything on that core.
Even if it's a multi-process, like you fork exec, if you fork exec it won't, surely.
I'm not sure if you fork exec.
With Python multi-processing, you would be able to run it on different cores. Again, it'll have its own gotchas in terms of degree of elegance that you're able to achieve there. But it'll do what Pat wants to do with multi-processing. You can make it so that you have it on different cores, and you can use whatever APIs Python tells you to use in that scenario, and you can share the data. It's possible.
Okay, thanks for helping me understand that.
That's all from my side. Thanks.
I think Kareem's up next. Good job, Chris.
I guess we've got a very short update on the pickups of those Pioneer 3 AT robots. Some views inside, and I'm going to ask David to go ahead and put words into my mouth. He's showing his shot of the one that he picked up. So 2 of them have been picked up already. Third one, we have an appointment to pick up next Saturday. Inside, there are 12-volt motors. And I'm going to very briefly show screenshot. So these are the motors that appear to be inside the 349 ones. So there's a total of 4 motors inside, and 2 of them have the encoder as pictured here on them, and the other 2 are sort of slave to them. So they're in 2 pairs. There's 2 motors ganged together with a belt onto 2 wheels on the side. So they all turn at the same rate, and there's a single encoder running it. We haven't. I don't know if David has powered it up yet, but I'm not aware of anybody powering up these motors yet. But they should be 12 volts.
So is that the actual asking price there? Almost $900 for one motor?
That would be like a new price, and this appears to be like a Chinese site or something like that. The Pitman motors were really, really nice motors, and the specific ratio on these was like 38.3 to 1 or something like that. And yeah, they're definitely on the pricey side. They're not what you would call hobby grade, but I don't know if this is a reasonable price. These were, and this is like a new price, and these are from 2006, I believe, from the photo. So.
Kareem and I were talking this weekend. We've always bought these Pitman gearhead motors with the nice optical encoders on the back from Tanner's, back when there was a Tanner's, and he'd sell them to us for $18 or $20 a piece. And when we went and looked up online how much, I just want to buy a couple of new ones, they were like $500 or $600. I was stunned at how expensive they were. And, now without Tanner's. So,
and those were much smaller motors.
Yeah. This box here has probably got, $4,000 worth of motors in it.
Shoot.
All of them move, right? In other words, what I'm saying is that there's no locked up gearboxes or anything like that. So no electrical power has been applied yet, but you can the robots around, and they move freely. It might be showing that right now. Yep. They have 3 hot swap battery bays that would take those 9 amp hour 12 volt SLA batteries, pretty common format. And that we would have to probably adapt the batteries if we wanted to go that route, so that they make contact with the hot swap locations inside of there. But they also have an onboard charging circuit. Again, we have no idea if any of the electronics are good, and we're not planning on, I'm not planning on, or I was never betting on using the onboard electronics, with the exception of maybe the sonar drivers, and we'll get to that in a second. And it looks like they might have a decent H bridge for the motors, right? Because those are pretty high amp motors. So that you would assume that that's a tuned H bridge for that kind of load. And so maybe there's a chance that we can take advantage of those. You were going to say something, Dave?
I just noted that the ones Kareem did just an outstanding blacksmithing job of straightening out the bent bumper on the front end of this one. And I was quite impressed, Kareem. But what we noticed was that every one of these has the sonar arrays, which are what stick out the furthest in the front and the back, were bent up. And it suggests to me that these, we guessed maybe 25 pounds, that's without batteries. And with these great big honking Pitman motors, 2 of them in parallel for each side, that it probably moved at a good amount of speed, and that the software that whoever was working on was not sufficient to avoid running into things. The actual profile of the front end is just right, because the front end is receded back from the front edge of the wheel, so it can climb steps or go up curbs or things like that. but the sonar arrays do stick out, and all of them were bent.
There's a lot of damage to the sonar arrays. So I was suggesting maybe, depending on who picks them up when, that, somebody lucks out and gets really, really bad arrays, that some of us might contribute some good sensors back, because the number of usable sensors is lower than hoped, and they were all all of the arrays were that was the primary location for damage, and some of them are cracked. There's one that's just incredibly mangled, so that's going to be a bit of a chore. But we did figure out some ways to sort of rebend the aluminum back, and so I think David's are in pretty good shape now in terms of
You did
the
a great
overall
job.
structure. Yeah.
I will say this, if we're talking about 8 sonars front and 8 sonars rear, and they fire them in sequence from their board. And it turns out there's that little adjustment I found on the bottom is to adjust the time space between pings.
Oh, so you can do that not in software, but just physically twiddling it. Yeah.
They have it set to 40 milliseconds. And they're going to fire in sequence. So that's 16 times 40 milliseconds, which is, that's a long time to get a 360-degree scan. We might want to think about, I'm not 100% sure that was a great design decision on their part.
Yeah, but it was common of the time, right? So
yes.
You would see these arrays of sonar sensors all the way around a robot.
All the way around.
Yeah. Typically, more often than not, they were circular. These are sort of 2 arcs on the end of a rectangular chassis.
Yes.
And a pretty good degree of range. I guess you could, in software, prioritize the direction that you're traveling in, because presumably that would be a higher priority. But yeah, that was clear that whoever, I think it was probably a university program, and probably student programmers that were experimenting with these, and they took a fair bit of abuse. But the chassis themselves are still really solid. The wheels are all in good shape.
And these were, as memory serves, these were like $15,000 a piece or something like that. They were new. You remember the number, Kareem?
I saw numbers depending on the configuration, anywhere from as low as like 12,000 up to about 25,000.
So the hardware is really nice. I mean, the motor mounts, the motors, the axles, the bearings, the drive belts, and everything.
Yeah, it's top rate.
It's really great stuff. And Kareem and I were talking about how these were things that we lusted over 20 years ago.
Mm-hmm.
That we just now can afford to buy, now that they're all beat up and old and nobody wants them.
Yeah, it will be a chore to resuscitate them, but
the hardware is beautiful. It really is. I mean, it's really nice.
So, yeah, I'm thinking about keeping another one of them for myself at this point. So I technically have one more that's not. I've got a lot of soft offers at different price levels, but I'm determined to, basically to offer that last one at 500, to if somebody wants to go for it. Still not, and if nobody does, I'm fine. I'll throw it on eBay.
Well, I would say that if you just bought it for $500 and took it apart, the wheels, the bearings, the motors, and the sonar.
I don't want somebody to part it out. I want like collaborators.
I'm just saying it's well worth $500.
Yeah, no.
Paul, Paul. You need one of these.
I've got enough projects.
Oh man can't have too many robots.
David's volunteering people. I love it.
So we'll, I haven't even had a chance to look at mine. I haven't even looked at the health of the sonar arrays or anything like that. I'm just too busy at the moment. So hopefully I'll get to it soon.
Well, I put out the effort and found the right size Allen wrench.
All right.
Which, as you
There's
may remember,
something we know. Yeah. What was it? I think we were using a T10 or T8, something like that, the torques. You're muted, David. Oh, well, that's helpful.
It's SAE 5/64ths.
5/64ths.
Your old standard 5/64ths.
Yeah. Got lots of those floating around.
Yeah, I was surprised. I was expecting it to be metric, but it's not.
Yeah, no, everything on that robot is imperial. But it was USA made, so makes sense. That's all we had, I think. So looks like we're done. Does anybody else want to claim some time?
I can show something I found that might be of interest. So let me click on.
Somebody's 3D printing something.
That'd be me.
So there was this that I saw that I thought was sort of interesting because it has no controller in it, but it bounced. I'll speed up this a little bit. And we're almost to the spot where they started up.
So it's using some sort of angle sensor against the floor.
So, okay, and so how they do it is sort of interesting to me. It was. So I'll scroll down so you can see the picture on the inside. So they basically built their little tilt switch with a long
it's like a pendulum switch.
engine.
Yeah.
And he talks about, absorb versus, and there's all the parts that needed only. So
it stays up most of the time.
Well, golly, it actually did. I mean,
a little hard to steer away from the edge of the table with only one axle shaft going straight through.
And then there's one of the stretch you see, and then the other one's inside. So
I can tell you why that really doesn't work. I experimented with this before I built my first balancing robot, because the pendulum there, it seems intuitive, but the pendulum there reacts not just to the pull of gravity, but it also reacts, as Einstein taught us, to the accelerations of the
it bounced back and forth
of the box itself. And there's no way, again, as Einstein taught us, to separate out which of those forces are gravity and which of those forces are momentum. So you can't really make a cool balancing robot. You can make a thing that bounces back and forth and mostly doesn't fall over.
So I thought that
mostly is good enough sometimes.
Well, you could say the same about me.
That's right.
I mostly don't fall over.
And then the other thing was, this was a little more realistic, where you could use an arm for a clock. So I thought that was.
Oh, that's one of those Me Too arms. That 3D printer. I got parts for that laying over here in a box.
In this case, it picks up numbers on a conveyor belt type thing.
That's cool.
And then puts it back and pick up another number when it needs it.
I mean, that's really cool.
Parts. So I thought that was sort of interesting how they, have a pickup robot sort of part combination to make a clock.
It's kinetic sculpture, I believe, is the term.
Cooper, most all real industrial robots don't use steppers or DC motors at all. They use hydraulics.
Yeah.
And hydraulics, a whole lot of the problems go away when you do it with hydraulics. They're so strong. There's powerful. They don't take up any room, you know. You might think about that. You can buy little hydraulic systems, you know, go online and poke around. There's things that would be, you might have to sell your car or.
Well, no, you can use the syringes for, they have, as I said, go small first and then scale up. So you can get simple plastic syringe type things I've seen, and they use cardboard even. So hence, you don't have to get that fancy to begin with.
Duct tape
You
and
can probably
baling.
get a 20-year-old ABB robot for dirt cheap, a robot arm.
It's a lot of dancing at Chippendales for that, though.
Actually, I was doing some quick calculations with the current like on-hand stuff that I have. This flip sky motor, to be specific, and the gear ratio that I have with it. Assuming I didn't quite look into the torque calculations for tooth engagement, but I should be able to get about 3-4 pounds at the end effector, assuming a near zero weight arm, which is impossible. So I mean, obviously that's just going to go down, but I think that'd be a good place to start. It's just with what I have.
With hydraulics, we move 20,000 pounds, about 36 inches in about 0.35 seconds.
You can get the real flats for a car where it's 2 tons and a little jet. You don't have to put too much pressure on the pump to get that. So, as I said, there are ways you could do it relatively cheap. I mean, you basically get, a real jet from Walmart or Harbor Freight, put more on the end there to do the pumping, with sonar and that, and yeah, you have 2-ton jack basically.
I don't. I think that would be very good for about the 0.3 seconds that the 3D print holds up.
No, I'm saying buy the actual jack. You can get one for like $17, give or take. That has a like 3-inch lift, and it will raise the car up to 2-ton. See, that's why I say I would combine a couple things together to get it, and then you would need a real sonar to do the pumping part. But I mean, it doesn't take that much pressure to pump on those things.
I see.
But that's an example.
Now we're talking about steel arms probably at that point.
Oh yeah. Well, some
heavy duty welding, heavy gauge welding, and stuff like that.
Then you got to get it back down again. Usually those things are just like unscrew the screw and then push it back down.
Right. But that's a one direction. But you can get 2 direction. If you go to like Tractor Supply, or look up Tractor Supply, and you go look on like the front loaders on tractors, and that there'll be basically a cylinder with 2 inlets into it on both ends.
This is not something you want on your. This is not
Oh
something you
my
want
wall.
on your desk or on your wall hanging over your head,
Yeah.
slamming
Stud
around.
finder work.
Yeah.
Or in your living room, period. Yeah.
This is not an indoor robot we're talking
Oh.
about here.
Oh, software overflow.
Yeah.
Oh, start small. Work with the plastic plungers, that you can get.
Maybe if you're building an exoskeleton.
Yeah. Hacksmith style, yeah. I definitely think I'm gonna start with this. I just remembered that that 3-pound figure was actually with an efficiency of the belts of about 70%, which is just like shoot for the worst.
Much higher. It should be much higher than that.
Yeah, so
Belts
that might.
efficient.
I don't know. I just have to. I'll definitely come back next week with what I can get done. I mean, I'm a student after all, and I've got another robot to work on, as it were.
Slightly higher priority, I'm gonna say. Yeah,
maybe just a little, huh?
I'm gonna put my coaching hat on there. Yeah. How many weeks until regionals?
Well, I believe that's
Do you really know?
2.
2.
Yeah.
Tomorrow.
Tomorrow. Goodness gracious.
I've heard sleep is overrated.
Yeah, you'll get all the sleep you need when you're dead. That's my saying anyway.
Or else hope that there's another ice storm. But nowadays with virtual, that doesn't really help too much.
Yeah.
Well, and who was it? Was it Kareem? Somebody in this group said, you know what? This emergency ice storm we just went through, what they call in Boston, they call it winter.
It wasn't me, but I'll take the credit. That's fine.
You-
All right, I'm gonna sign off, guys. It's been nice
Good
talking
idea.
with you.
Me too.
All right,
Yep.
See you next week.
Night, everybody.
later.
Y'all take care.
Bye.
Night.
Carl, you got everything?